Hey guys, we're going to continue our study of simplifying radicals, this time with variables in the radicand. When your radicand contains variables, and remember your radicand is the value under the radical sign, which operation do you use to simplify? You use division. And when the variable's exponent in the radicand is larger than the index, you divide. The whole number is the outside exponent. And what's left is the inside exponent. When the variable's exponent in the radicand is smaller than the index, you leave the term under the radical. Now, hopefully you will see how all of that comes into play as we do the 6 practice problems here together at the bottom. So problem number 1, the square root of 64 x squared y cubed z seventh, is really saying take the square root of 64, multiply it by the square root of x squared, multiply it by the square root of y cubed, and multiply it by the square root of z to the seventh. Remember, when there is no visible index, that is an understood 2, and we really need that when we look at these variables. So we know the square root of 64 is 8. Now here's where the division comes into play. 2 goes into 2 one time. So x to the first power. The square root of x squared is x. For the next one, 2 goes into 3 one time with 1 left over. Notice we have 2 goes into 3 one time with 1 left over. 2 goes into 7 3 times with 1 left over. Put all your terms together on the outside, all your terms together on the inside for your answer. 8x y z cubed square root yz. All right, problem number 2. I'm going to put problem number 2 in a different color so that they don't all run together. The square root of 24 times the square root of x cubed times the square root of y to the fourth times the square root of z. Remember, you have that understood 2 for each of those. And you'll get to a point where you probably don't need to write that in, but now is okay to do that. All right, the square root of 4 times the square root of 6 breaks down 24. 2 goes into 3 one time with 1 left over. 2 goes into 4 two times. And this is where, when the variable's exponent in the radicand is smaller than the index, you leave the term under the radical. So put them all together. The square root of 4 is 2x y squared square root 6xz. Problem number 3. The square root of 125 times the square root of a squared times the square root of b to the 10th times the square root of c to the 5th times the square root of d. Notice it doesn't matter how many terms you have, you still do the same exact thing. So the square root of 125 is the square root of 25 times the square root of 5, which is 5 square root of 5 times square root of a squared is a, square root of b to the 10th is b to the 5th. 2 goes into 5 2 times with 1 left over times the square root of d. 5ab to the 5th c squared square root 5CD. Problem number 4 has a variable that does not have an exponent greater than the index, so it stays where it is. So we really just need to break down the square root of 68. The square root of 68 is the square root of 4 times the square root of 17 times the square root of x, which is 2 square root 17x. Problems 5 and 6 have coefficients out front. All you do is multiply at the end. Treat it as an outside term. So 3 times square root of 9 times square root of 2 times square root of x to the 9th. 3 times 3 square root of 2 times x to the 4th square root x is 9x to the 4th square root 2x. And our last problem here, problem number 6, is 4a times square root of 10 times square root of a cubed times square root of b to the 9th times square root of c is 4a times square root of 10 times a square root a times b to the 4th square root b times the square root of c. Outside terms, 4a times a is 4a squared, b to the 4th square root 10abc. Now, I did not do this for you guys a while ago, so if you will add this in, this would be great. Right down here, if you just put your box for questions. If you have any, please put them in the box. If you do not, great. But please make sure that those questions get asked in class. Don't forget to scan your notes into Canvas, and I'll see you guys soon.